And I think that we are live. Welcome, everyone who is watching, and welcome, Lucas. Thanks for accepting my invitation for um, for this talk tonight. We're gonna
Thanks
have
for inviting me.
that we are. Thanks
I
for no problem at all. Sorry, I think we have some return.
Yeah, it was me.
Okay,
I
no
think
problem, no
now
problem.
it's you.
That's perfectly fine. So again, welcome everyone. This is the GDG Cloud London last event, last talk of the year of the 2021, and so happy to see you here. How many people we have now? Two watching, so we can be more. Let's wait. I don't know, 5 minutes. Let's warm up the situation. So Lucas, how you doing? I know that
Okay.
you recently moved from Brazil.
Yeah, I recently moved from Brazil to Sweden, so
All
I'm
right.
now in Stockholm. We had our session last wait 2 weeks ago, I think.
Yes, I think
Uh,
yeah, a couple of weeks ago, I guess. Yes,
yeah, I
yes.
was well. I moved, as you can see. I'm not in the same scenery anymore.
Different background. Yeah, I noticed.
Background. So uh, I'm pretty okay. Like I'm still getting used to the moving, still getting used to
Yeah,
things, and everything happening. But it's
makes
been
sense.
nice. It's been cool. I'm loving it.
I want to ask you, how did you find the different weather? Because
Well,
I guess it's different.
yeah, like Brazilian weather is when I well, this is my experience. I don't know, but
Yeah.
I went to Italy once,
Okay.
and Brazilian weather is pretty much the same. It's hot
Yeah,
and
it's
quite
very yes.
humid,
Hmm.
but I don't like hot places. So one of the reasons I left was actually because of the weather. I don't really like
I
hot
I
weather,
feel you. I feel you. I feel you. Yeah, I perfectly understand.
and now
So
I'm just here like -15. So
welcome to Europe. Welcome to the very cold weather, snow and ice.
yeah,
There will be a long winter ahead of us. So uh, don't don't give up.
never.
So I see we are 10 people now watching, more or less, I guess, because one it's me checking the stream. So welcome everyone. Thanks again for joining us. As I said, this is the last event of the year for GDG Cloud London, and tonight we are going to talk about gRCP with Node.js. You will learn about it in a few moments with our friend Lucas Santos. Thanks again for joining us. Um, so we will do this. The talk is more or less 50 minutes of presentations and a demo, if I understood. And at the end there will be some space for questions. For we'll do some Q&A, and also here there will be a raffle at the end of this talk. So everyone listening, there will be a raffle. So if you wish to win a discount code, 100% discount code for one JetBrains product of your choice for the duration of 1 year, I'm asking you to post something on Twitter using a specific hashtag I will give you in a few moments. So at the end, I will use Wheel of Names to pick three of you because we have three discount codes, and it's completely random. So I can say good luck, post good screenshots, good pictures, make us to appear good, and yeah. So this is what I have to say. Hi, Ivikas, welcome.
Hello, how are you?
Hello. So I will post this in the chat soon. So there will be the hashtag. You will find it there. And yeah, this was me. I will leave the stage to you, Lucas, for your presentation. That will be awesome and interesting because I read something in these days. I'm a little bit prepared. So welcome again. And yeah, good luck. Enjoy the talk, everyone. I will
Thank
share your screen here, and here we go.
Yeah. So let's talk about gRPC with Node.js. So basically, I'm gonna present myself first. I'm Lucas. I am a software engineer at Klarna. I don't know if you heard about Klarna. If you're from EU, Europe, United States, Australia, you probably have. It's a bank payment method. If you're from Brazil, you probably don't know what I'm talking about because we don't have these things in Brazil. I'm also a Google Developer Expert and a Docker Captain. So you can find me on the Google Developer Experts page and the Docker Captains directory as well. But if you want to talk to me about anything, I will be present in basically all social networks. So all you have to do is put the name of the social network and lsantos.dev, like we have down here in any browser. So you're probably going to be accessing my websites. If you just put like lsantos.dev, it will be directed for like basically all the sites that I have. So go there, ask me questions. I love to answer questions, and I love to do talk about technology and how things happen. So let's go. So in this talk, we're going to talk about gRPC. So basically, I'm going to explain to you what is gRPC. I'm not looking at the chat in general, but I will ask Rosano to ping me if there is anything, or just put the questions on the screen. I'm going to answer. You can ask over there, and you can also ask me after the talk. My slides are going to be on my Twitter. So you go twitter.lsantos.dev. My slides are going to be over there. So let's start. So what is gRPC in general? So gRPC was developed by Google in 2015. It's an implementation of an RPC protocol. So it's open source and it lives in GitHub. It uses HTTP2 as a transport layer, so it can multiplex the information that it sends. And like RPC is not a new concept. We'll see like in the next slides everything that it has to do with RPC itself. It stands for Remote Procedure Call. It's something that's been around for a while. So we're going to explain what it is and how it works. And RPC is basically a remote calling of a method, so which is present on a server. And we call it through client interfaces, which are fluent. So you have the same client interface calling a remote method on a server as if it was local. So the other thing that we're going to talk about, which is unrelated to gRPC, but needed in gRPC to work, is Protobuf. So Protobuf is an interface definition language that we're going to check it out soon enough as well. And gRPC is actually interoperable among all languages. So what it does is actually the same thing as REST do. It's basically the same stuff. Some say they are like competitors, but I don't think they are really competitors. But they do almost the same thing with some smaller differences, the thing that we're going to see soon. So basically, this is a remote procedure call using REST or using gRPC diagram. So the diagram is basically containing an implementation. So here we have on the left-hand side, we have a C++ server, which is the service runner. So it has all the implementations for the methods, and we have several clients wrote like in Ruby, Android, and whatever. And we have this gRPC stub. So what are those things? So I'm passing my mouse through the screen, but you're not seeing anything, right? So I'm just stop doing it. Basically, in the client code, we have something that's called a stub or a skeleton or a client. It contains a wrapped representation of a network call to the server. And the server has all the method implementation and everything that is communicating with the client. So basically what we do is that when we call something in our client, this client can be like whatever thing you have, like a class or maybe an object or something. You can call a client.method, and it's going to get all your parameters. It's going to serialize them using Protobuf, and is going to send this information to the server using HTTP2. So it's a binary data that's going to be sent. So this is the first difference between gRPC and REST. It's all binary. So both the headers and the payload is sent in binary. So this is something that REST is different. But one of the things that we need to know is that gRPC is actually not new. RPC is actually not new. gRPC is a concept that's pretty new, like from 2015, but the concept of RPC comes like from 1970s. This concept like was first implemented by Bruce J. Nelson and a few others at Xerox PARC. So basically, the idea was that RPC, remote procedure calls, were going to be used to intercommunicate processes in operating systems. So basically, it's still used to do that. So a process can communicate with another process through an RPC, remote procedure call implementation. Another thing that does this pretty well is concurrent languages like Erlang or Elixir. They have native implementations of remote procedure calls. So remote procedure calls are basically the concept, and gRPC is an implementation of this concept. And the G doesn't actually stand for Google. It doesn't actually stand for anything. It changes at every revision. So basically, it's just a G. So one of the other things that we had, the original implementation for the RPC, they are a bit far away from what we understand today. So what we are doing today, actually, in terms of using the actual usage on web and things like that. So one of the most famous lookalikes of gRPC and RPC was something called JRMI, which is basically Java Remote Method Invocation, and RMI is another name for RPC, which is just Remote Method Invocation versus Remote Procedure Call is just the same, but RMI is the OOP equivalent of RPC. So both gRPC and JRMI have a stub or a skeleton. So this is the client, as you can see here on the left side. We have a client, we have a remote object interface, which is just the class, and it wraps around a stub. A stub is just a network call that calls the server, which has the remote object implementation. And this skeleton on the other side gets this call and translates this to a local method calling, and then gets the result and send it back to the client. So basically, it's just a disguised network call in a way that it's easier for everyone to understand, right? Yeah, I'm looking at the question. So Jan asked that in the REST world, there are tools like Postman, which makes it easy to work with REST. Any recommendations? There is another client, a gRPC client. One of them that I used a lot is, I think it's Crew, something like this. It's almost look like Postman in general. Basically, let me see if I can find this. We have no. Let me see. Well, one that I found here is gRPCOX, which is a something like Postman. They actually says it's like Postman, but for gRPC. But the other one that I use, Kreya, KREYA. So this one is another client that's basically the same as Postman. The only difference is that, as we're going to see in the next slides, we use Protobuf interfaces. So these Protobuf interfaces, they have really specific implementations that we need to address when we're using gRPC clients like these. So basically, this is going to be something for a bit different when you're going to test these things. But we do have similar tooling to Postman. So yeah, this is one, Kreya app. So this is the one that I'm talking about. So after we understand how actually gRPC works on both sides, yeah, Christian, a front-end app can call gRPC server. There is an implementation called gRPC web that you can implement it. I don't think it's production ready yet. I don't know, but it works. It works quite well, actually. But it is not meant for React. It's meant for web in general. It's built in JavaScript, so you can use it in the browser. Like, it's pretty nice and works. So it's a possibility. So yes. So after we understand this method invocation, how gRPC actually works, let's understand the other part, which is Protobuf. So Protobuf is the second part of gRPC. They're not actually related. Protobuf can be used standalone, as we're going to see later. But gRPC uses Protobuf. They are completely different projects. Protobuf was developed, I think, in 2009, so it's pretty older. It's another version. I don't know if you work with Kafka or RabbitMQ, but Apache Avro is one of the things that I most like on it. So it's open source, developed by Google as well. It's a mechanism for serializing. It's a protocol actually for serializing structured data into binary formats. So you can actually get an object and you can get the representation on this object into a binary data, a binary buffer, and you can send it over to whatever you want. And if you have Protobuf on the other side, you can decode it in that language. So it's not language specific. It can be used in a ton of languages. So it has like Ruby, C, C++, JavaScript, Go, and Java, C#, like you name it. So there's a lot of things. And you can actually use Protobuf to do a lot of stuff. So it's pretty neat. I use it all the time. gRPC, it's widely used for microservice interconnection because microservice should, in theory, be alone. So it needs to be a single service, and it often needs to interact with other systems. So what a better way to interact with other systems than having the system as a gRPC client. So you just instantiate this client and you have all the methods that you need to call it, and it's pretty transparent to the one that is calling the method. So basically it's just another class or maybe another object in your system, but under the hood it's doing a lot of other things, and it's pretty neat to see it working in microservices. It's actually Protobuf alone without gRPC is actually widely used in messaging. So RabbitMQ, Kafka, most of these messages are encoded with Protobuf and decoded on the other side using Protobuf as well, so they can be passed on along. So this is another implementation. And basically, Protobuf is a IDL, what we call an interface definition language. So an IDL is literally another syntax, another language, and it compiles to several languages, different languages like Ruby, JavaScript, and things. It creates actually objects, and you can interact with those objects. But some, like it says, I put here that it requires compiling. So yes, it does require compiling for if you're going to use it standalone, like I mentioned, if you're going to use Protobuf with Kafka, RabbitMQ, and so on. But if you're not going to use Protobuf alone, if you're going to use gRPC, you can't load it dynamically. You can load the Protobuf file and compile it dynamically. So you don't need to compile this in runtime. You can compile this actually beforehand. You can compile it in runtime. So this is what a proto file, so .proto file, looks like. So we start with this. We need a syntax, and every message is either a response or a request. It's basically a payload. So the message is a payload, and it defines the content of something that we are actually going to send. And as you can see, we have IDs in front of each field. So we have 1, 2, 3. Those are actually enumerating binary fields. So one of the things, this is actually what I really dislike about Protobuf, but I see the necessity of it. One of the things that the creators of Protobuf said, well, let's do this so we can get messages to be smaller and lighter. How can we do it? So if you take like JSON or XML, you have a lot of characters that are kind of useless to us, to the system, like the brackets or the tags. So we don't actually use this. Or maybe the quoting, like these are only for syntactical purpose. The columns, the name of the fields, they are only for syntactical purposes. And JSON is XML is pretty huge, as we all know. But JSON was built to make XML more compact. It was created to do it. And we have like a human readable form. So JSON is very readable. We can read this, we can understand it. So it's a format that it's in the middle. Like it's not completely human readable, it's not completely machine readable, but both can read it. So in order to do that, we need to make some sacrifices. The greatest sacrifice was the size of the object. So the object with the same data in JSON have like more than double the size of the same object encoded with Protobuf as binary, because we don't need these control structures. We only need byte arrays. So to understand, the way that Protobuf understands which field is which, we have these indexes. So the first field is a name, the second field is an ID, and the third field is the adult, which is a Boolean. So basically we have the index, the ID of the property, so which is a string, if it's an int, if it's a Boolean, if it's other type. So this is another ID. And then we have the size of this. So there are 3 bytes that represents three things that can be represented in JSON with, I don't know, maybe 10 kbytes or something more like this, right? And then we have the value of this thing, and then another breakpoint and another thing, so on and so forth. So in general, Protobuf is way, way smaller than JSON because it serializes everything in binary, but we can't read anything because it's sent over as base 64. And well, it's not human readable, it's not intended to machines. So this is something that Protobuf does to keep all the fields in order to deserialize it. So it gets the field number 1. Okay, so what's number 1? Number 1 is name. So let's put this string in name, and this is how it works. We have a name for the message. It's only for us in the definition language, but it works to let us understand. And if we compile this, we have a nice little tool called ProtoC, which stands for like proto compiler. And we extract the JS output out of it. So basically we run this and we install the ProtoC compiler in our machines, and we run this. We are saying that we want a JS, so JavaScript output. We want the import style to be CommonJS, not ES modules without import, so required. We need the binary to go inside the proto/gen directory, and the proto file that we're going to compile is this message.proto that we did here. So the output is going to be something like this. It's going to create another file called message_pb.js. So this is a simple glimpse. I don't know if you can see much of it, but the idea is that it's generated code, and it's going to generate all the needed methods for you to create these messages, like this one. Let me return. So it's going to create all the necessary tooling for you to encode, decode, get all the fields and things like this using this message. So this is just a snapshot of a few lines because this is insanely huge. It's probably like 1,500 lines or something like this. It's huge. But it's just for you to have these sorts of methods. So you have a lot of getters, a lot of setters, like get ID, get name, set adult, get adult, and it changes. You can have like arrays. You can have like a repeated string, which is an array of strings. And if you have a repeated string, an array of strings, then you have different methods here. You have set, we have add, remove, we have several other stuff. So basically, you have the person class, and you can actually use it. You can have new person inside your code, and you can serialize it using serialized binary like this, and you can deserialize it using person.deserialized binary and sending over the proto request. So this is something. So basically, this is what I'm doing. This is a simple snapshot of what we do here. We can import it like we would normally do. We extract the person interface, we create a new person, we can set the name, we can set the ID. Then if we console.log everything, you're going to see that it's not a common object. If you can see on the right side here, just after the first debug message, it's only like a wrapper, and we have an array index offset, the array, which is the the values that we have, pivot, and a lot of other things that are not actually an object, the person object. If we serialize that into binary, then Protobuf is going to start acting, and all this data is going to become an array of 9 bytes. So it's uint array, uint8 array. So it's an assigned int of 8 bytes array, 8 bits. And basically this is it. And then we can deserialize this. So the person deserialize binary, and we pass on the binary and get the name. Like we can get normal.getName, and you'll see that it's Lucas that is returning. So basically, this is only Protobuf. You can use Protobuf alone. So if you don't like gRPC, you can actually use Protobuf. So this talk has 2 sides. So you can, if you don't fancy using gRPC, you can actually, and you like Protobuf, you can just use Protobuf. And well, I hope you like this as well. So this is actually why Protobuf's so good, because we can save a lot of time and a lot of bytes sending over. So if you have like microservice communication, you can greatly reduce the latency among the communications on it. So it's pretty nice. But as I said, gRPC is different from Protobuf because despite they're being used together, gRPC implements the Protobuf infrastructure as a message layer. But they're not the same thing. They're different projects. They're maintained by different people. And basically, that's because Protobuf is, in fact, universal. You can use, as we could see, we can use a message. We can generate a message with whatever message protocol we have. So since Protobuf supports like a lot of languages, you can implement a strong message definition among several services using several technologies. So one example is what I said, to standardize messages using, I don't know, maybe RabbitMQ or Kafka clients. So you can actually type your messages among not only your code, but among an entire system, since you have a standard definition, right? So if you have the proto file, you have the source of the truth. You can download this proto file. You can actually go through maybe a server and get it on your cloud, well-known object. And then you can type everything that you have in a distributed system, which is actually pretty amazing if you're gonna ask me. But well, I hope you starting to like gRPC and maybe considering dumping REST or not. It's complicated. It's something that's been here for a good while, so it's pretty nice. I saw here Christian also asking, how does an endpoint look when requesting a message? I'm going to show you this on our demo. So actually in a few slides. So let's do it. Well, so gRPC is based on service. Hold on to that question, Christian. I'm really going to show you how we actually build a whole implementation on this. And I'm going to, if we have time, I'm going to show you a demo on this working. And if the demo works also, right. So a service is basically a group of method calls. It's like a class, and it specifies which methods are available for the client to call in the server. So this is all defined in the protofile. So we can, let's say we want to build an API. So basically, this is going to be our API, a Node API. So we can define a service by the Node service like this. And each RPC here is a route on a REST, like it's a REST route. It's called list. It gets a input parameter, which is void, which means that it doesn't receive anything. We are using void because Protobuf does not allow for empty requests. So we need to create our own. And it returns a note list. So a note list is just a repeated note, which is an array of this note message that we have here. Yeah, I guess the message interface has to be compiled on both sides, right? Client to server. It depends. It depends a lot. Like on JavaScript, you can use it dynamically. You don't need to compile at all. You can just point to a file. So if you want to get the latest version of a proto file, I'm going to talk about this con in the end. But if you want to get the latest version of a proto file, you can have like a well-known endpoint or a route somewhere that downloads the proto files and stores it on a temporary location that you can use on your application, and you can dynamically load it. So you don't need to compile this on both sides. You need to have the protobuf file on the both sides, but you don't need to compile them on both sides, unless your language, your programming language, needs it to be compiled. So if your programming language, if your gRPC client on your programming language of choice needs it to compile the proto files, like JavaScript doesn't need to, but it can. So you can actually compile the proto file and import it as a statical dependency, but as a static dependency, and you can use TypeScript on it. But if you don't compile it, it's going to work the same way. But we have other languages. I think C doesn't allow you to do it. You need to compile it first and then load the compile. So, but you have to compile the application anyway. So, well, those are other problems. So, yeah, this other question of how the endpoint looks like, I'm going to answer very soon. Actually, I'm going to answer in this stream here. So basically, what we are doing is now defining the service. I created another endpoint. The other endpoints are find endpoints. As you can see, we did a small change here. We removed the void endpoint like this, and we added something called a well-known type. So Google has a lot of well-known types. One of them is empty, which is just an empty object. It's pretty nice that you can actually import other proto files. So you can have like other proto files and you can import and compose them. It's pretty awesome. So you don't need to have, you can have shared types amongst the proto files. And it supports other stuff as well. It has a very long list of things that you can do with Protobuf. But it receives like a node ID. So each service, each RPC, each route can receive only a single parameter and can return only a single parameter. So basically we can't have like multiple ones here. So the message, it's a good practice to have a request message and request response. And we have two different types of messages for each RPC. So basically I would have like, I'm not using this here, but I would have like a find node request and find node response. So I would have only one in each one of those. Basically, our note ID is the one that we receive here. It's just a string with an ID and it returns the note. So it's just a note. Whilst here we are going to return a note list. So it's a repeated array of notes. So a lot of notes. And we have the types of methods. So the RPCs are actually methods, remote procedure calls. And we have a few types of them. So there are 4 types of methods. The first type is the simple call, which is what we call a simple request or a unary request. It's called unary because it's a unique request. So you're going to send something and you're going to get something in return. So it receives a single response for one single request. You can also have a second thing, which is a server streaming. So streams are very common in gRPC. You can actually use this to stream data from the server. So you just put stream in front, and basically what is returning here is going to be a stream. And you can actually, like this YouTube comment box on the right side you're seeing can be basically built with it because you can receive lots of streaming for comments in the backend. So you send something like the video ID and it returns a string of comments, and you can read this asynchronously. So it's pretty nice. gRPC actually manages everything for you, every stream and everything. We have the client streaming, which is the other way around. You're just going to send a streaming data and you're going to get, once this stream ends, you're going to get a response. So basically it's really nice when like uploading a file or something like this. You can have client streaming. And the last one is all together. So we have a bidirectional stream, which you send a stream and you get a stream back. This is trickier because you need to manage 2 async fluxes. So basically you're sending something in real time and you're getting something in real time, like you're sending a file and you're getting back the progress of the upload or something. So basically it's trickier to do it, but nothing that you wouldn't do. And it's not impossible. So now we're going to show you how to build this thing. So basically what we do in JavaScript, in Node actually, we install a dependency called gRPC. We have other dependencies. This is easier right now, but this dependency is quite outdated. I have another example on my blog Unfortunately, it's in Portuguese, but you can just translate it. I'm gonna send I'm gonna actually look for it first, and then I'm gonna send the link. It's pretty translatable, but what matters is actually the code. So this one I'm gonna send here in the private chat, and Ross can actually get into the chat. So basically, there is another project ongoing, which is basically at gRPC. It's a scoped package slash gRPC. So the only thing they did was that they took it off the Protobuf loader. So in this package, you load the Protobuf and you actually do the code in the same place. And when you're using at gRPC slash something, you actually have to install two packages, one for loading the Protobuf and the other one for loading the gRPC interface. So after we install it, we're going to make a small change here just to make it easier. We're going to return to void because I didn't download everything that I need. So I didn't download the proto file for the empty, like Google Protobuf and so on. But here is what it looks like on a dynamic loading. You can do grpc.load. If you have the second most updated one is going to be protoloader.load, and you're going to require a path which has the path for your proto file. And this is our database. So basically, I'm not doing anything so fancy here, just an example. So we have a list of nodes, and we're going to download. We're actually going to create an API to get these nodes. So then we are going to implement the functions on the server side. So each function, each RPC call is going to be a function. So we have to go to the list, and each function receives two methods. The first method is the call, the request, and the second method is a callback. So yes, gRPC works with callbacks, but you can't do it with promises. You just need to convert this to promises. It works just the same, but you need to call the callback, and the first is the data that you want to return, and the second one, the first one is the error if you have any, and the second one is the data. So it's going to do all the things alone. You don't need to check for errors. It's going to return an error if it finds an error. So the second one here, the list one doesn't have any input parameters as we could see in the proto file. So we have a void and we return a node. So we're going to list all the nodes. So basically return all the nodes. And the second one, defined, it receives a request ID. So the call object has a request, and the request has all the parameters. So we receive the ID, and we return all the nodes that match that ID. So basically that's simple. As you can see, it maps directly to the same thing. And we need to have the functions, the implementation functions need to have the same name, including the case as the service. So list with a capital L, find with a capital F, as you can see here. And if you're using TypeScript, which I really like, you can actually compile your proto file and type all the things. So in my blog, this is a 4-part article. In the third part, I do it with TypeScript. You can take a look over there. It's pretty nice to see. The other thing is that we can start a server. The gRPC server comes along with the gRPC package. We add our service where we dynamically load the service. So we have node definition, node service, and if we put like this full service, like on the RPC interface, like this. So on the right side, if you see like node service, it's the same name as our class over here. And then on the second parameter, we pass on a object with the implementation parameters for each one of those. So basically, it's an object with all the functions that we implemented. And then we bind the server on an arbitrary port. In this one, we are creating a credential, a secure credential, but we actually need to use this in production. If you use this in production, you're going to need an SSL certificate because HTTP 2 requires it. And then we start the server. So basically, that's it. So it's the full code. So we have 3 parts: the loading part, the database part, the implementation part. So these are the most important. And the other one is basically the running part, where we put it all together. We glue everything together and start this using gRPC itself. So it's not that difficult. It's pretty straightforward. And the documentation is also really good for this package. But in general, this is something that I'm going to talk about. gRPC has a very sparse documentation, specifically for JavaScript. it's worse. But let's create the client. So the same thing. This is, let's assume this is a separate service, like a microservice that's running in China, and we're here, like I'm here in Sweden, and this is running in London, maybe. So we have two different services running in different places. We're going to install RPC here, and then we are going to load the same proto definition. This is what you asked, Christian. So basically, we can load and we can compile things. So this is the same thing. You can load dynamically or not. And then we are going to create a new client for us. So in the client side, we are actually create a new node service, and we're going to put here the name of the server that's going to be called. Like, so if I'm here in Sweden and we have another server in London called, like, I don't know, maybe grpc.london.dev, I'm going to put grpc.london.dev in the open port and the credentials that I need. So again, if you're having this in production, you need an SSL certificate. It needs to be the same on both sides so we can match and do the right handshake. Then we can call our methods basically the same. So this is the magic, the beauty of the thing. So what we can do is that we are calling our method as if it was a local thing. So we created a client here, and basically we have all the methods that are on the server locally. So we have the first object, which is the request parameters, and the second one is the callback. Again, we can change this to an await expression or a promise expression. It's fairly easy, actually, like you would do on any callback application. You just pass it on a promise inside of it and then return the callback result. So basically what we do here is that if we find an error, we return the error. Otherwise, we log the notes. The same thing here, we pass on the ID. And then if we find an error, we throw the error. Otherwise, we don't find anything, the note isn't found. And then we actually do console log that note. So basically, this is the implementation of the client. So nothing too fancy on it as well. So let's try to do a demo here. Let me just take it off here. Where is, so Ross, if you can please share my screen on the other side. I have YouTube, oh, here. Awesome. So for this demo, I am using this repository. I'm not seeing what you see is what I'm seeing, so I'm not seeing any questions. So this is my GitHub, and you can see in gRPC Node.js demo app. So everything is here, and the code is actually running here. So what I have is a Node server.js and a source client.js, so we can start the client and the server, and I can compile this. But I did install Protobuf Pro-C in the dependency, so you're going to have to install it yourself if you need to run this. But this is what it looks like. So I have a proto file. This is the proto file, and it's exactly like the one that I showed you. And then we have a notes pb.js. As you can see, it's a pretty large file. It has 685 lines. And it has, like, let me check if I can get the outline here on the right side. So here, as you can see, I have like a lot of objects. So void is one object, serialized binary, the serialized binary, and we have note ID. We have, where's the note? Note here. So we have the note, we have the serialized binary, we have the get ID, get title, get description, and we have the notes, note list here. As I said, we have, this is an array, so we have a add note and a clear note list, so we can add new notes or clear the array. We have the set note list if we want to replace the array, so this is different. But all this is generated code. We don't need to do actually anything. And we do have the Node.js. This is the first thing that I'm doing. This is the first example that I showed you. Zoom set, no. So this is the first example I showed you. So basically, this is a node that we are using on Protobuf alone. So you can check it out. So I create a new node here, definitions.node, and I can serialize binary, deserialize binary, and we have a node list. So a node list, we can add a new node, we can serialize this, we can receive the list, get the node list, and loop through it like we do here, right? So let's go to what matters on the server side. The server side is basically the same as I implemented. So we do have a find function here. We have a list function here. So we're just gonna return a find here. Basically, we add the service. We are gonna run in this port, and this is the client. So we're gonna get a random one. So between 1 and 2. So or 3 actually, because we have 0 and 1, no, 1, 2, and 3. Yeah. So basically, we can't have a node that's not found. And basically, that's it. So if everything goes as I am planning, I can go npm run start server on one end. Of course, it didn't work. So what is the problem here? Could not load file notes. Oh, that's because I am not starting it from their name. Right? Probably. Yeah, maybe. Let's see. So yeah, so as you can see, we are being prompted to use this gRPC protoloader thing, which is actually recommended, but it's the same thing we're doing here. The only thing is that gRPC protoloader is separated from the gRPC interface. It's just newer. And then on the other hand, we're going to do a npm run start client, and hopefully it's going to answer to us with the notes. So if I run again, I can probably get a note 1 or note 2. No, I'm just getting, oh, here, note 1, right? So I get a note 1, and then here a note 2. So I'm communicating with this server. As you can see, it's pretty silent. It doesn't do any logging or anything. But as you can see, let's say, I think it's 1 and 2. Let's return something that we don't have, like, where's client? Let's put 3 in here and save it. And we can have node 1, node 2, node 1. Yeah, just because I wanted to have a, oh, here. So we have node not found. As you can see, it didn't find any nodes. So our implementation is actually working. So basically, this is how you build a gRPC server. It can be a lot more complicated than that if you want, but I'm going to talk about it in soon enough. So Ross, can you put back the slides, please? So now, since we are doing the demo, we did the demo thing. It's pretty simple demo. You can actually try yourself, download the code, tinker with it. Please do. If you can actually commit this. It's not my computer here, so I don't have the access to commit to my own repository. But I'm gonna fix this as soon as I can. But well, let's talk about the not so nice things about gRPC. So basically, docs are not very common. It's very sparse, especially for JavaScript, because it was not intended to be used with JavaScript. So for Go, for Ruby, for C, C++, it's awesome. But for JavaScript, it's not. It's really weird. So it does have a few weird things. We have some companies like Uber that are doing a lot of good work trying to standardize stuff, but it's not very common to have docs. So the initial development is quite complex if you don't know what you're doing. So, yep. It takes a while to learn, so there's a learning curve. But once you do it, it's pretty straightforward and pretty simple. The only thing that you need to do, one of the things that we wanted to do, is to add the capability of having gRPC clients using only promises. I was doing it, and then I couldn't finish. But usage with TypeScript requires some work as ever. So TypeScript is not like normal in the JavaScript, so it's something that was added later. So if you want to use gRPC with TypeScript, some things you're going to change. Like the first thing, you need to compile the gRPC definition, the Protobuf definition, because it needs the typings. So we have a compiler, when you have a plugin for the compiler called gRPC, Proto-TS, I think. Protobuf compiler, TS, gRPC, TypeScript compiler, something like this. And it requires some work. You need to include this compiler. And once you run like Protobuf, Proto-C, it's something like this compile command, it's going to output not only the JS files, but also the .c .d definitions for the types, as well as the clients and everything else. It makes it a lot easier because it actually creates a client for you. So you just need to instantiate the client. You don't need to do anything else. So it is a bit complicated to understand the initial idea and the concepts, especially if you're not a experienced developer, because it actually needs to, it needs you to understand how HTTP works. It needs to understand. It needs you to understand how web actually works, how requests work, how do you communicate with a server and the text. It's not advanced as well. It's like intermediate or something, but it's not definitely not beginner stuff, right? But we have an advantages of the gRPC interfaces because it's way smaller due to binary transfer. So you can actually reduce a payload size up to like 90%. And this is just talking about the payload without the rest of the thing. But yeah, you can reduce something like 80%, 9%, 90%, because we get rid of a lot of things. So we don't need a lot of stuff in the middle. It's HTTP2 by default, so it's newer, it's safer, and it's faster. You have simple client calls. It's not difficult, as you could see. Client.list, it's a call and works. It's awesome. It's lighter and it supports like a lot of calls. It's really, really, really resilient. So you can bombard it with a huge amount of requests it can take to handle. And it supports streaming on both the client and the server, which is amazing because you don't need WebSockets to do connections. And as we know, maybe if you don't know, WebSockets are a pain to escalate and to scale up. So it's complicated, but gRPC makes a bit easier to do it. I'm not saying it's the solution. In fact, it has almost the same problems as any other WebSocket, but you don't need to deal with the connection or the life cycle of the thing. So it takes a huge load off your back. And the best thing of gRPC, in my opinion, is the Protobuf. So Protobuf, it standardizes the message exchange among the client and the client and the server. But there is one con on the Protobuf side. And Uber is actually working on something that's called Buff, but I don't think it's going to be ready anytime soon. The thing is that Protobuf doesn't have a package manager. So if you need to import other proto files, or if you need to store proto files, you need to have your own place. You can download proto files from like GitHub or something like that, but proto compiler, it doesn't follow these links. It's not like Golang that you can put the whole repository URL and it's going to download the thing for you. So basically, you need to download them manually for now. So I am really interested in creating a proto compiler, a Protobuf package manager, because it will really help a lot on this. But it needs some things. Buff is intended to do this, but it's way more complicated because we have imports. And when we have imports, we have circular dependencies, tree shaking, and like all things that package managers need to deal with. So it has its pros and its cons. Probably this is why there is no Protobuf compiler yet. But this is a comparison of calls. Like it's a time to execute 1 million requests on this. And if you have like an empty response, if you have a single book, an array of books, this is REST HTTP 1.1. So the bigger, the worse. So if you go up, like it takes more time to execute. And if you go down, it takes less time to execute. So if you do like the keep alive stuff on an empty response, this is obviously going to respond a lot faster because it's an empty response, but it's not that far from a gRPC interface. In all other cases, gRPC wins in the other cases. But the only thing that you need to keep in mind is that keep alive keeps the connection running. So you keep a socket actually open on both sides. So it's bad to have a socket open at all times when you do this. Well, these are some refs that I used to get this talk. Well, returning. And here down below, there is a link to my repository. And I don't know if I have a link to my blog. No, I don't have. But I do. I'm going to edit this and make it work. Well, so thanks a lot. I hope you have enjoyed it. And I hope you could listen and learn something new. And if you are here until the end, then we're going to do something amazing and give you licenses.
Yeah, you're right, Lucas. Thank you so much for the talk. It was very interesting. A couple of things I didn't know. Thanks. And the demo was just great. I saw your code in there. Cool stuff. So let's see if there are questions in the chat. I don't think so because you've been so great being able to answer them in real time. So I don't think we have other questions.
Let me
Is there a
run here.
solution? Oh yeah, okay. One question came in. Here we go. This
Solution
is all
for RPC
yours.
by Swagger. So it doesn't actually need the RPC one. I don't know, like the conceptual RPC thing. I don't know if there is a solution for RPC itself, but a gRPC doesn't actually need it because you have Protobuf. So gRPC. Okay, so gRPC it doesn't have it because you have Protobuf. So Protobuf is your Swagger implementation. So if you read the proto file, you can actually see what's happening. I don't know if we have like parsers that can translate your proto file into a usable web interface or something, but I don't think we do. It would be a nice solution though, but this is kind of unnecessary. Like, oh, contract testing. Contract testing, I think we don't have anything like this, but it's pretty easy. It's pretty easy to do. Like we can actually, you can download the proto files. This is the problem, like I was talking about. You need to download the proto files from a single repository, multiple repositories, and then you need to, create your endpoint testing on your own. So basically what you do, you can match your calls with the entire gRPC definition, Google endpoint use what they call internally smart docs. What do you mean? I didn't understand this. Google endpoints. Oh, what? Oh, okay. I don't think I can answer that because I don't think I know about it, but I'm gonna really look into it to check it out. Sorry for not answering it, but I'm really gonna have to look this. Oh yeah, so apparently we have some couplers to OpenAPI. So we have a lot of things. Tibor, do you have use cases as example? Yes, I do. Actually, I not mine use cases, but Kubernetes is based a lot on gRPC. So a lot of things that run on Kubernetes is gRPC based, especially the operators like Keda. They are really run on gRPC stuff, and they communicate with gRPC internally. So Kubernetes is one of the things that run inside. Actually, depends a lot on gRPC. Other companies that actually use them is one of them is Google. So obviously, it uses their own creation, and everything that probably you're going to see, if you look into DevOps for a while, you're going to see a lot of things that use gRPC in general. So the company that created gRPC Web, if I'm not wrong, is called Improbable. And Improbable is a multiplayer gaming platform. It provides like backend for online games and such. So they use gRPC a lot to do streaming communication among the game clients and the game server. So they are actually one of the companies that have contributed the most to gRPC in general. So they do have a lot of those things. So if you have microservices as well, you're going to have a lot of things that use it. So if I'm not wrong, I think Netflix used this a lot as well, but I'm not quite sure if it's true or not, because I've never seen them talking about it. I think that,
Cool. And I think that will be all for questions.
yeah, those are actually awesome questions. Some of them I never
Very interesting.
think about.
Tibor saying that makes sense. Can be used in a serverless manner.
Yeah, gRPC is great when you consume it as a serverless function. You can use it. The problem with the serverless side of stuff is that you need to have the proto file. So it's not actually a problem, but like let's say you have a Lambda function or a Google Cloud function or a Azure function or whatever, you can create it to download the whole package. Like when it spins up, you can download the latest version of a proto file. You need just to compile it ahead of time and then give the gRPC interface the definition of your service, and it's going to download and use it as simple as that. The only thing is that you need to keep this file with you. So Protobuf is actually the greatest and the worst thing gRPC has to offer in general, because it's both the solution of most problems as well as the cause of most of them. So it's pretty tense when you do this. But I've never tried. If you do, please let me know. It's a nice use case. We have a lot of other questions. Awesome, you're great.
We
You,
do, we do.
yeah, you think it's worth the effort, or it would go be better to jump up to Kotlin or Golang? Uh, okay, so if you're using GraphQL, I've never used GraphQL on Kotlin. I never actually coded in Kotlin, but I used gRPC in Golang. And Golang is actually pretty neat with gRPC. It's actually nice to see it because it's typed. It creates the types automatically, so you can do it alone. It's awesome. You can use both, since GraphQL and gRPC are just communication protocols. You can actually intercommunicate in whatever you want. So I would go to gRPC first if it's more mutation stuff like posts and you change data. If you have streams. But if you do have like a lot of GET requests, if you're gonna get a lot of data, you can use GraphQL. You can use actually both. You can use GraphQL as a endpoint where you can actually gather data using gRPC in the resolvers. So if you want to mix everything together.
Lucas, you have time for last two questions?
Yes, I do.
So there is one from Christian. He's
Oh,
asking how to handle versioning here with gRPC.
the ugly way. We have to create, well, Uber says, Uber, when I'm saying Uber, it's like everyone that's using gRPC, but Uber is actually leading the effort. They have a best practices document. In this best practices document, they say it's better for you to version your proto files using Java class notation. So the reverse DNS notation, like com dot some, com dot something, dot something. So let's imagine you have a repository called like this repository I have on GitHub. So we have com dot GitHub dot the node gRPC node server, and we are going to have like slash v1 slash the proto files. And if we have v2 slash v2 slash the proto files and so on. One other project that uses this a lot is Containerd. So if you use Docker, you have already seen Containerd in action. I have a few talks when I actually connect Golang with Containerd using gRPC. And Containerd, if you go to github.com/containerd/containerd, you're going to see all the proto files. And this is the structure I'm talking about. They have like several versions of it. So it's not beautiful, but this goes to our next questions from the Protobuf problem may be solved with a private NPM. Yes, it may. But the problem is that Protobuf is not, the proto files are not a package JSON, right? So if you import another proto file from another source inside your project, you need to know how to get this, and you need to know the exact location you're going to put this. So I think the one that actually best approaches what would be like to do a Protobuf package manager will be like Golang. Golang does what actually it's most likely the best thing to do. You put a URL, it saves everything inside a folder, and then it points everything to that folder. So if you import stuff, so basically you're gonna need to rewrite your proto files constantly. So this is something that now you can see the struggle why we don't have a package manager yet, because we can't actually get all those things talking amongst themselves without hacking a lot. So basically this is it. And we have one last question. So it's good JS lambdas with gRPC. I've never seen them. If I did, didn't know, but it's definitely possible. So I don't know if it's going to be something that would actually be different or not in general.
All right. Lucas, what can I say? Thank you so much for your very interesting talk, and the content was very, 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 very interesting. Thanks everyone for the questions and the participation. So now we are going to proceed with the raffle. I prepared already the wheel, and I noticed that we have only 3 people having shared something on Twitter using the hashtag I gave you. So I guess the raffle, it's not a raffle because we have 3 codes, 3 licenses. And yeah, you won, guys. Let me share my screen. Maybe I can show you. Here we go. You see it, folks. There is GDG Cloud. That is us resharing, retweeting. And there is Manuel DevOps, Vikas Gupta 1812, and Wojtek 7078043. So, folks, I'm going to ping you. I will send you a message on Twitter, and you tell me how you prefer receiving the code. You can send me your email, or I can send you the code directly on Twitter. We'll see. We'll see later. No problem. Lucas, again, it's been a great pleasure having you here. And yeah, you want to say something?
Nope, just thank you for inviting me. It's been amazing.
It's been great. It's been
meet again soon in a
absolutely
personal
next
event.
year.
Now that I'm really closer to you guys, so
Yeah, time zone now is not more a problem.
Yeah, not more
It's just 1 hour if I am correct.
Yeah, 1 hour.
So it's
I'm
perfect.
1 hour after you. So
yeah,
awesome.
It's perfect. So you are almost bedtime. So I leave you. I let you go. Thank you, everyone. Thank you, folks, for joining us. And Merry Christmas, Happy New Year, everyone. And see you next year. Bye. Thank you.